through the Earth. He has built some scalar communication systems. He's built a whole series, a rather large number of different kinds of scalar antennas and scalar detectors. He's worked out a beautiful series of very sophisticated detection instruments that allows him to detect scalar waves from storms, scalar waves that are placed onto weather and so forth by the Soviet Union, measure the scalar taps that the Soviet Union has placed into the Earth itself and put the Earth in scalar resonance, and he has in fact mapped the entire scalar resonance frequency responses of the Earth up to quite a large number.
Where does he work?
He works independently. He's an independent inventor all by himself. He's also done some extremely fundamental work in the field of boosting up the power of radionics. We had the privilege of being present when John Bedini took his scalar wave detector and measured that instrument and proved conclusively it does put out scalar waves. He's done a large number of things like that. Ramon Sanchez, our named Professor Sanchez, has done a lot of experiments with scalar in the microwave frequency, like 5 gigahertz and so forth, with the beams and crossing the beams and extracting energy and the little cold explosion over water and so forth. And of course, I named John Bedini. Didn't give a complete list of names, but those are the main ones that I had named. I named Howard Johnson. Howard, as you know, has a patent on a permanent magnet motor, and Howard personally demonstrated to me that he had a rotary device, and he personally demonstrated to me that he can make a North Pole attract the North Pole, and I'm telling you, anybody can do that, can make a motor.
Where's Professor Sanchez based?
He's in Los Angeles.
And he said he's done a lot of mapping of scalar potentials.
That was Frank Golden.
Oh, okay. Well, have either of them published the results anywhere?
No. They don't intend to.
Why is that?
Well, for one thing, you get yourself threatened if you do. For another thing, if you publish real definitive results and you're trying to be an inventor, what you wind up doing is giving away your invention. And so many of them are trying to bring certain things to the patent area so that they can market them and then go ahead from there.
So publishing, C. Craig, is not the reason for invention. The reason for invention is to move it into the marketplace.
Well, sure.
Now, I would name some other folks. I would certainly, I have the greatest admiration for Professor William Tiller, who's built a very fundamental detector, in my opinion. I have done some enormous work in all kinds of areas that are on the far-flung frontiers of science. I have great admiration for Dr. Robert Beck, who has personally demonstrated at some personal expense and some hazard to himself, scalar communication systems, or scalar transmitters and receivers that go through Faraday cages, and he's done a lot of work in ELF and so forth long before it was fashionable to know the effects of those kinds of devices, and so I'd certainly include him in the area. I would include people like Bill Bice and Dr. Elizabeth Rauscher, Pete Kelly in radionics. Certainly I would include Dr. Hieronymus, the founder of the modern phase of amplified radionics. I would include him as a very great inventor and pioneer in this area.
So there's a lot of work being done by a lot of people out there, Craig. And,
I know that.
And they're very impressive people, and their work is very, very impressive.
The problem that they have, Craig, is that because it's unorthodox work, there are no provisions for funding in this area. There are also no provisions for a lot of the things we take for granted in science. For example, if I want to do research in ordinary science, I can go down to the library and I've got the resources of the world at my fingertips. If I can't find a book or a paper anywhere else, I can get it directly out of the Library of Congress long enough to get a copy. But in this area, there's not even anybody doing card cataloging or cataloging the material or digesting the material or giving you an abstract or a review of what it means or anything like that. We don't have the resources or anything to do that. We don't have really good journals in this area at all because nobody has the monetary resources to do that.
Right.
We could certainly get along a lot faster and a lot quicker if we did have some resources to set up the standard things you'd like to do to be able to share all the information with everybody else starting anew.
Right. Well,
one of the things we can tell you we are doing, this show will be made available on cassette form. We'll tell you more about that, but You're getting a lot of information here tonight from John and from Tom, and that will be made available to you very quickly.
The reason I asked about publishing is, since you're asking people to do research at universities, I would think it would be very helpful to those people, or to motivate those people, to give them something to work with to start with.
Bill?
If there was published information.
Craig?
Yeah.
We will make available a tape on the pendulum generator.
I think you ought to say that louder, John. I don't think that came over too clear.
We, excuse me. I had my mic off.
Yeah, turn it back on.
The little things. We will make available a tape on the pendulum generator, Craig, with laboratory measurements, orthodox rules.
So that you can see it all.
So that you can make it yourself.
And with that, we're going to have to run, Craig.
Right.
And I appreciate your questions. They're always very thought-provoking, and that's the reason I give you a little extra time.
Okay, I appreciate everything you're doing up there.
All right,
Down
thanks. Down, yeah, you're way up in Northern California tonight.
Right.
Thank you very much.
Bye-bye.
I'm Bill Jenkins. With me, John Bedini, Steve Worth, and Tom. Dave. Hi, Dave. Welcome aboard.
Hello, Tom. How are you tonight?
Fine. How's it going, Dave?
Very good. Now, I think I want to ask Mr. Bedini the first question. On the return from the battery to the motor, what is that direct from the battery back to the motor, or how is it wired?
I will explain this to you.
I'm just interested in the return to make the full
The
circuit.
return path is nothing more than a pulse.
What's the electrical connection?
The electrical connection is as the monopole portion of the magnet goes past the generating coils.
Right.
The motor turns itself off
Yeah.
after the push.
All right.
You then supply the pulse energy back to the battery through a rectifier. So what you're looking for is a current with high potential. You want a high voltage spike back to that battery. This then is...
That comes out of the induction coil, the pickup coil, right?
That's right. That's exactly how this system works.
Yeah.
And I will tell you that I disconnected them tonight to bring them to KABC.
Yeah.
But the pendulum has been running for about 14 to 15 days, constantly. If you want to measure the battery right at this moment, I will guarantee you that it's at 13 volts.
13-volt battery.
Well, it's your standard lead-acid cells that make up a 12-volt battery.
All right. What's the output of the motor then?
1.2 watts,
For the voltage.
12 volts.
All right.
And it will run down as low as 5 1/4 volts.
Yeah.
Will push the pendulum. But I don't worry about what's going in. I worry about what's coming out and being returned to the battery.
That's right.
You see, if you can engineer a motor that never draws any more current, you've just beaten all the theory.
Yeah, but you're using a cobalt magnet too.
Well, I could use a regular barium ferrite magnet. I can still engineer the same system given any set of tools.
What about using something like a plutonium magnet?
I don't know of one. Maybe neodymium iron. That's the newest one that I know of. I've never heard of a plutonium magnet. But
It would be expensive, I know that.
Yeah. All right, now, I think that answers that question now. I think Mr. Bearden, are you there?
Yes, I'm here, Dave.
All right.